Okay, welcome to our second class of Cybersecurity Trustworthy AI. This is Module 1B, and we're going to be going over AI lingo through the eyes of some actors and look at some true stories, which implies that there are some fabricated stories here too. All right, so here we are, Module 1B. And this is going to go over those chapters that introduced Jane, Miguel, and Ernestine. 3 characters. Now, there are a few people at work that are kind of like these folks, but I thought it would be fun just to fabricate them a bit and go over their roles. They play key roles, and also you're going to meet Brian, Don, and Iniko from, I guess, there's 2 chapters on true stories, one at the beginning of the book, one at the end of the book, so I did a mix of a few of them. And that's kind of what's on the agenda today. If someone who has a large language model access on their phone could ask for a random word, share that with me, share that with the class, and that'll be our random word for the attendance. And all you have to do is on the subject line, put that word. That's all you have to put. And away we go. I hope you all have the book by now and read and scanned through chapters 3 and 4. We're going to go over quizzes 1 and 2 at the end of this class today. And we are going to have some homework, which is to read chapter 5, which is on prompt engineering. And you're going to see, you just saw some prompt engineering at work. And then go ahead and take the quizzes for chapter 2 and chapter 3. Or would that be, wait, chapters 3 and 4. I got that wrong, sorry. Chapters 3 and 4, I'll fix that. All right, and if you want to snap a photo, I'm going to snap a photo of you in a few minutes. Do you think we have a quorum here? Maybe I'll wait 5 more minutes. If you haven't already, grab a piece of paper, grab a marker. There's a few floating around. Put your first name, and in the chat, I'm going to snap a picture of you. So I have for attendance. This says 11. Anyone else need one? All right. Pass it down. One more piece of paper. Anyone have any extra paper there? No? I got some. Oh, you need one?
Oh, I was just going to ask a question.
Sure, go ahead.
It says chapters 1 and 2, or like at least 1 is due on September 11th, so I was wondering.
Yeah, I was a little liberal in the for the first few classes on when you actually have time to do it. We're going to go over them in the class, so when I say they're due, I'm going to give you the answers. So
do you recommend that I do them before we go over it?
Yeah, I would recommend it. Remember I told you this is the least stress, most learning. Not just least stress, but so I need one? Oh, got it. All right. Okay. Sure. And there's markers floating around, so pass them up. Good. We have a good class today. Got a couple new folks as well. All right. Let's go. Now, in the book, notice it's a student's guide to AI's building blocks and the personalities that put them into play. I briefly mentioned last week that understanding technology is one thing, but technology doesn't just poof into existence, deployed and everything. It takes people to do that. So as we look at the tech, we're also going to look at it through the eyes of the people who get paid to work with the tech. And as I gave you some insight last week, the folks we're going to see and the roles that they represent in a company are a big deal in 2024. And I suspect strongly that in 2025, 2026, 2027, they will do nothing but continue to grow. Another hint, think about this, a combination of computer science, cybersecurity, and AI, that's a big deal. Not just any AI, trustworthy AI. So you're going to hear this in their stories, whether they were real friends of mine or fabricated friends of mine. You're going to hear that tone. They're not going to brag about how much money they make because they're fairly humble folks, but they are going to talk about the importance of being ethical and elements of trustworthiness. I'm going to show you a few videos of some of this in action. All right, so from a learning objectives, the standard learning objectives is that understanding how AI works with humans. So I had an error in my code, and AI just didn't come up with it. I could have cut and paste. If my brain was at rest and I just didn't want to think, I could have cut and paste the error into ChatGPT, and it may have given me a hint as to what it was. But since I've experienced that before, I said, oh, double quotes. So it was a team. It was a team effort to get that result. It wasn't just AI. And prudence. Again, it's software. It's pretty cool software. Understanding it, demystifying the magic is what we're here to do, and you're going to get your first dose of that today. And today we're going to continue on our AI fundamentals. In the book, I throw a lot of terms out. And I think I was debating whether I should do that early in the book, at the end of the book. But I have this thing, which is sometimes if you just sit in a room and hear people talk about something, you get the terms, and it starts to sink in. You've heard them. I've heard this before in a context. So I'm not expecting you to know every single term here, but I want to expose you to these terms. So I asked DALL-E 3 to create a rendition of the AI lifecycle and the personas that play against that lifecycle. Does anyone know what a lifecycle is? It's how something goes from the start, the middle, and the end, right? So it's the progression, it's going to be a CI/CD pipeline, around a piece of code. Someone develops it, someone tests it, there's documentation, there's security tests against it, and then there's some deployment scripts written and it gets it. That's the life cycle. So AI has a life cycle. And I told you what AI does, you can pick Spot AI. It doesn't spell very well when it's doing images. It makes me laugh sometimes when I see this. So I superimpose. Actually, this is the diagram I gave it, and along with a few instructions to get that. So this is the life cycle on top of a typical AI life cycle. You might find 10 variations of this out there, but this is one that I feel pretty comfortable with. And then what I do is I map the role of the person or the group of people that are performing this action. So data preparation, that's a data engineer. Model development, that's a data scientist. Prompt engineering, etc. Model development, deployment, application integration, and then ethical compliance. Right, so that's kind of the role. So we're going to see a few of these folks come alive today, if you will. And the first is Jane. Jane's a data engineer. So that's the data curation, data preparation. And you're going to hear mentioned several times, Jane probably has amongst the most important roles, maybe the most important role. It's where it all begins, and AI is rarely ever better than its data. So Jane has a pretty important role. And let's have a chat with Jane. So, hi Jane. Jane says hello, and she's a specialist in curating and preparing diverse data sets. And I'll ask back, nice to meet you. Tell us about your role. And Jane's going to say, well, with my expertise in data management and processing, I take great pride in ensuring the data used for training AI is both ethical and high quality. And I'm surprised she responded to, I'm not maybe completely surprised, I'm glad she responded this way, I should say. Is that it's not high quality first, it's ethical and high quality. And I remember that she's part of this team who's working on sustainability, just to get that confirmed. And she said, yes, the environmental sustainability project is what I'm working on. And it's an exhilarating opportunity to contribute to a greener world by providing data-driven insights, recommendations for individuals, businesses, and governments. If you notice in the book, I did take that theme of environmental sustainability. I'm not sure why I picked that theme. I want to leave the planet the way we found it. I don't know that I'm a naturalist or environmentalist per se, but I think that's one thing I believe in. So it became a theme of the book. And there were some really good data sets, public free data sets that I was able to use in the book as examples. That's another reason why I did it. Okay, so that's Jane. Exactly. Don't worry, Jane. You're in class. Jane's a little suspicious. You should be suspicious on who you're chatting with. So in Jane's world of data curation, this is some of the lingo that she might use in an average day. And you saw it put into play a bit more rigorously in the book around data processing. This notion of data labeling for one type of AI, and I would say for all types of AI indirectly, that labeling is a really important aspect. And as I mentioned last week, if you go through something you would know, like attributes about members of your family, chances are if you go on the internet, you're going to be able to outdo the internet in information about your family. So in order to outperform the internet or outperform ChatGPT or Perplexity.ai or any of these public large language models, what you need to do is for every member of your family is to create a labeled data set. My brother is into sports, pain in the neck. Well, you go through, carefully curate, you create columns and you fill those in. And when you look at, and we'll look at next week, or in 2 weeks, some data sets, you're gonna say to yourself, oh my gosh, that's a lot of work to really do that. If you look at Netflix recommendations, the input data that goes into their recommendation engine, you're like, just give me the spreadsheet. I don't need an AI to recommend. I can just go look up in the spreadsheet to sort the columns because it's all there. And you wouldn't be wrong. Right? So data labeling is a big deal. I want to pick on that. So that's a term that Jane would use. Also normalizing the data, because some of the data might be in mixed forms. Like sometimes it might be in centigrade, sometimes it might be in Fahrenheit, sometimes it might be a C, sometimes it might be an F. So AI may or may not be able to sort that out. So as part of normalization, you go through the data and you decide which way it's going to be, and you normalize it into that. Okay? Data sets are the collections of data. When I think of a data set, the easiest way for me to visualize it is a spreadsheet, a comma-separated file, a table. That's typically a good way to do it. That data set becomes a training set, and we'll see when we pass off to Miguel. Not all the training set you're going to see you're going to want to use for training. You want to save some of it for testing, because you want to go back and test to see if it gets the answers you expect. So you usually give the model about 80% of the data set. You keep 20% of it, and you test with the 20%. There's data pipelines. There's data governance. Once you create the Netflix data set of all movies, directors, actors, year, ratings, and blah, 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 you're not done, because this year there's going to be a whole new set. So you have to govern, you have to go over and keep updating things as you go along. Just like a piece of code. It has a life cycle, it has versions and all of that kind of good stuff. Data privacy. We're going to talk about that quite a bit, but I'll put it on your map right now. There it is. And we're going to talk about that quite a bit, as well as data ethics. All right? So that's Jane's world. A very brief run into Jane's world. There's a lot more about Jane's. I think I picked Thursday, day in the life. It was Thursday in the book, and it was watching at what they did on Thursday. So meet Miguel. Miguel's a data scientist. Miguel works with Jane, and you're going to see. Well, let's talk to Miguel. My name is Miguel, and I'm the data scientist. And he has a little attitude. I think I was in the middle of something. All right, so just give me a minute. All right, give him a minute. Hi, nice to meet you. What are you working on? Well, I'm building a conversational AI bot to provide analysis and practical guidance on reducing carbon footprint, conserving energy, and embracing eco-friendly practices. Right? So you're going to see Miguel's role is going to be a few things, but on any given day, Jane and Miguel, data scientist, data engineer, if you're an engineer, aren't you a scientist? I mean, their roles are pretty close. So you're going to see he spends a lot of time in data and understanding which model, based on the additional data, which model should we start with? And we'll go into that when we talk about transfer learning. What are some of the tasks? So I select, evaluate, customize a language model for eco-friendliness. It's very rare in 2024 that someone is going to create an AI model from scratch. You know, I joke in 2024, there's no unique code. All the unique code that is ever going to be written has been written. In fact, the last unique piece of code was written by someone in 1987. I joke. That's the year I got married, so I don't know why. That's a joke. I mean, I'm sure there's always going to be unique code, but in this day, an important part of Miguel's work is to say, where should we start? My company can't afford to train only the Googles and the open AIs and maybe the IBMs and a few others could afford to create models from scratch. So which model are we going to start with? Maybe an open source model. Let's start with that. And then it's like buying a pizza. And I only buy plain pizzas. I buy just straight cheese pizzas. When I go home, that's when I dress it up. I'll make it into whatever you want. You want a veggie pizza? I'll work it. I'll bring the veggies. If you want a meat pizza, I'll bring it. It tastes better when you do it that way. And let's put it this way: it tastes different than the pizzeria. Maybe not better. It tastes different, and that's what's happening here. Miguel is going to buy a plain pizza, but the pizza that's closest to where he wants to end up, and we'll talk about that in a second. So here's a couple of relationship diagrams. Probably look at model, like if it's a language model, it's going to have to select the base model, look at ways to evaluate whether his decision is right, then how are you going to customize it? Inside the model, there are things like weights and biases, parameters and tokens. We're going to talk about these at length when we get to the chapter on machine learning. But you should at least know the terms. And of course, neural network. That is often referred to as the brain of AI. So that's around learning, reinforcement learning. We're going to see some cool examples of that in our machine learning lab. Fine tuning is when you take an existing model and, just like the name says, you tweak it to have it maybe excel in a particular area. So, as I said, like it might know about your family, but it doesn't live with your family. So you're going to tweak it and give AI some additional information that it didn't get from the world. Fine-tuning is a really important term. Inferencing. Inferencing is another important term. In fact, when you give ChatGPT a prompt, it's performing, it is now responding to that prompt. The term is called inferencing. That's what it's doing when it's doing that. There is often people will say, when you're working on a model and you're using hardware like NVIDIA chips as co-processors, they'll ask you, are you doing model training or model inferencing? Are you serving the model as if it were like a ChatGPT-like thing and end users are using it? That's inferencing. Or are you Miguel and you're going to train it? That's what I'm going to use it for. All right, and a few others. There are different types of AI. And when Miguel is choosing, Miguel has to know about the different types to see which one is the most appropriate for the problem. Now, they're building a chatbot, so it's going to chat. It's going to use language, so natural language processing is a big deal. Are they going to generate text? Are they going to do language translation or machine translation from French to English, English to Spanish? Are they going to be doing sentiment analysis? Are they going to be doing entity name recognition, text classification, question and answering? And so these are some of the things that Miguel goes through. You all with me? All right, before we get to Ernestine, let's take that picture. All right. All right, let's see. All right, I can get you all. Let me try this side because I got that thing in my face, the projector. All right. So let's see. Can I see everyone's? All right, hold it up without blocking your neighbor if you can. 1, 2. All right. We'll see what we'll see. All right. Ernestine is the prompt engineer. So Ernestine says, hi, I'm prompt engineer, and I play the matchmaker between the language model and meaningful chats, so our users fall in love with our eco-friendly chatbot. Nice to meet you. What is prompt engineering exactly, Ernestine? Well, it involves the art of crafting and customizing prompts, a skill used to elicit accurate and contextually appropriate responses. Elicit accurate and contextually appropriate responses. That's what you're trying to do. You're trying to elicit a response by saying things, saying the right things, giving enough context, etc. Can you give us a tip to be better prompt engineers? So I like to say, in the voice of Ernestine, I like to say context is the cue. So context clarifies content, enhancing relevance in responses. So if you're saying create an image, it's a Victorian London scene, it's foggy evening, bustling carriages with pedestrians. Right? And it's a pretty robust query. And I think that'll get a nice response. Okay. Hey, Jerry, aren't you one of the guys that invented the bubbling, the deep ... That's not relevant for this class, Ernestine. Maybe. Okay. So, what are some of the terms? Probably the term that you hear a lot in the world of prompt engineering is prompt shots. So, is it a 0-shot prompt? Is it a 1-shot prompt? Few shot prompt? All this means is, along with the prompt, how many examples are you giving along with it? And 0-shot is no examples. So what's the meaning of life? I'm giving you no clue, AI, as to how to respond. You figure it out. Well, what's the meaning of life? I'm living in Raleigh. I'm in NC State. And you give it some context. You give it some examples. And now it'll give you a more contextually relevant response. We're going to talk a lot about RAG, Retrieval Augmented Generation. What does that big term mean? Very simple. It means you're giving as context a richer body of information. For example, I might say, search this website and respond with the results, summarize the results that you find. Or here's a document on some environmental protection agency legalese, and I'm not a lawyer. So explain this PDF in 100 words in plain English. Give me a summary, right? So retrieval augmented generation is your friend. And I was so glad about a year or so ago when some of the most popular chatbots started supporting the ability to drop a document on them. And now it's like, whew, all right, get some time back, okay? So let's see. Ethical prompting, prompt evaluation, we'll go over that starting next week. Our whole class is dedicated to this, all right? So that's the first part. How are we doing with time? All right, so this class goes till 3:50, all right. So we're going to go through some true AI stories now. Those 3 stories were somewhat fabricated, up based on people I know, and these stories are people I know. So the first story you're going to hear is from my friend Rushir. Rushir was on the Watson Jeopardy team when Watson played Jeopardy, if you've heard that story. The game show Jeopardy that used to be on TV, I'm not sure if it still is. At one point, IBM Watson challenged the leaders. Rushir was one of the engineers on the team. Now he's focused on AI for code. And without further ado, I'll let him explain that.
A question that has inspired computer scientists for decades is about, can we build machines that can program themselves?
Can you guys hear?
Now, to answer that question in its essence, we really need 2 aspects. First one is intelligence. In other words, I would say artificial intelligence, AI. And the second ingredient needed is for machines to be able to understand their own language. I would say code understanding. Code understanding. To result in an area that we are going to dive deeper into today called AI for code. If I now look at significant problem, one pillar which was most important among that, I would point out that will be data. In fact, even among data, a particular data source has had a pivotal role to play in this. That data source was called ImageNet.
ImageNet.
It is said that there is no AI without data. And in fact, I would say there wouldn't have been the latest incarnation of AI without ImageNet. This was a data set that had 14 million images and 22,000 classifications. This resulted in breakthroughs in algorithms that we are reaping the benefit of in other modalities as well, like natural language processing and beyond. And we believe that the breakthroughs in natural language processing can not only help us understand human language, but they actually can help us understand machine language as well, in terms of machine language understanding, machine language reasoning, machine language explainability, and so what is needed for AI for code. And same 3 pillars which were foundational for progress in AI will be needed for AI for code progress as well. And then the second question arises, what is our ImageNet moment? And in fact, very recently, we announced the ImageNet moment for AI for code, called CodeNet. CodeNet has, just like ImageNet, 14 million code samples in 55 different programming languages, and to top it off, 500 million or 500 million lines of code. It's a massively large, first-of-a-kind data set which is available to researchers and developers alike in open to be able to make massive progress in a code language translation. Code debugging. Developers spend most of their time not just writing code, but most of the time they spend debugging code. For a machine to be able to generate new code, the nirvana is, imagine the scenario where rather than people just leaning on keyboards and typing these programs to be able to build applications that we utilize every day, for us to be able to talk to machines, and they actually generate the code automatically. So code generation from natural language. Code performance improvement. My code doesn't work as well. Can you make recommendations to improve my code's performance? Code memory, all of these 3 together to give rise to massive innovation which will result in answering the question that computer scientists have pondered for decades. Can we build machines that can program themselves? And I think we are closer to that reality than ever before, and I'm looking forward to the progress in this area. Thank you.
Okay, I hope you can hear that fairly well. Just a quick summary. Unsurprised, Rushir said, teaching AI to code starts with data. And he referred back to something called ImageNet, which really kicked off this notion of large language models, large image models. It's 14 million sampled images with some large number of classifications. You know, this is a cat, this is a dog, etc. Similarly, groups from Red Hat, IBM, Microsoft, and a few others created CodeNet, which has 14 million code samples and 500 million total lines of code across 55 different languages. And that is become the foundation for AI for code research. And again, a lot of these models now can code fairly well, and you can trace its history back to some of Ruchir's work, which is pretty cool. All right, quick pause again. The subject word for attendance today. Did someone pick a word out?
Serendipity.
That was last week.
I like to ask
That's come on, ChatGPT. Pick another. Ask it. Pick another random word. Pick another.
I've been here last week.
Yeah. All right. What do you got?
Buoyant, Ebullient.
Oh, okay. I believe if I had something to write with, I would write it up there. But yeah, that's one heck of a word. What is it?
An expo.
Do you have an expo? Can you write it up here? That's the word. Sorry, I'm not AI. I don't pick the words. All right. There's a great analogy here, the carrot in the blender analogy. And the thought there is, you know, did I mention this the first day of class? I'm not sure if I did. But the carrot in the blender analogy is you go to a party, you know, a smoothie party, and you bring carrots. And they start using your smoothies, and you're sitting down and someone says something, maybe that, so subject line, and that's your attendance code. And someone says something to offend you, maybe, I don't know. And you abruptly decide to leave, but then you said, I'm not leaving without my carrots. So can I have them back? And the host says, well, carrots are gone. They're in the smoothie. And so it's like the equivalent of this, right? So like, there it is. It's like, you want your carrot back? There it is, right? So the analogy, and I have to give Ruchir credit for this analogy, is that traditional AI models blend code and data, making original sources close to being indistinguishable and untraceable, right? So that's what you get. And this is the root of like copyright issues with AI, and you know, being able to have it unlearn things that it may have been trained on that wasn't rightfully meant, you know, from an ownership perspective, it to be trained. So it's the way I like it, because it helps me with a very impactful way. You're not getting your carrot back. So you're not getting your data back. It's in there now. And I think it's one of the big research problems that folks like myself and Ruchir have been working on for the last couple of years. That and hallucination. But code originality is a big deal, or information originality. You know, why are you saying that AI? That's why I like Perplexity. I think I mentioned this. Perplexity AI does a really nice job of tagging information as to, giving you this answer, this is where it came from. All right, this guy has the coolest job that I know. And it's, if you read his history in the chapter, you'll see Brian has worked in some very interesting places. You know, he worked on the first talking Barbie. He worked on a bunch of toys with voices of all sorts. And then he found himself working at McDonald's Research on automated order taking, and has some really good insights around what they've achieved, but also the complexity of being able to use, in a noisy environment, typically audio capture to sort out what a person's trying to order. So here's a quick glimpse of that.
I'll have a classic cheeseburger with just an avocado and cheddar cheese. I mean, American cheese.
Also 2 large Cokes, an order of fries and onion rings.
Make that a chocolate milkshake and remove tomatoes from the first one.
For dessert, I'll have a brownie. Are we good?
We're good.
That's it.
That's just a very, very quick
And I'll have a
glimpse of it. But think about that. Noisy environments, multiple languages, you're synthesizing the voice back. What's the right thing? And one of the things that Brian says is they have the capability of making the voice quite convincible. That it really sounds like a human. But they backed away from that because once a person hears something that completely sounds like a human, they start really rattling and rambling, and AI can't handle that, right? So they almost purposely don't make it sound too natural so that you kind of know you're dealing with an AI versus with a person. So these are little techniques that in a real world setting, that's what, and then, operational efficiency, not just to mention the noise and getting the right speakers and stuff like that, and social impact. So I think that's some of the problems there. I'll keep going, and actually I had the pleasure to work with Don on this one. I mentioned it, the first class, the Mayflower project, which was the autonomous captain or the AI captain.
The ocean floor is littered with our engineering failures and mistakes. You need to respect the power of what happens out there.
There's still things to be discovered. If we have a zero risk philosophy, we are doomed.
When we first conceived of this idea, I wasn't sure it was going to be possible. We were talking about an intelligent vehicle out in the middle of the Atlantic Ocean.
We built a ship, put autonomy into it, and now we're learning what that means.
You just maintain your policies, The pressure is certainly building as we're getting closer to the launch. There's a lot that we need to deliver.
All right, fine.
Something going wrong.
What keeps me up at night is we break down somewhere in the middle of the Atlantic, and it's something so trivial.
Working on a boat like this, you kind of have to figure stuff out on your own.
It's a drama. No, we need to find out what happened. It wasn't responding. So we lost comms.
I just want to finish shaking her out and start a class.
The crossing.
The crossing.
So when you say the crossing,
Atlantic.
that little bit.
Yeah.
Yeah, good luck.
When it pulls out of Plymouth and I know it's not coming back for 6 months. When I see the rear end of it and the stern of it going around Ream Head, headed off west, that's going to be exciting.
IPM really likes projects that are really pushing the envelope to do really exciting and novel things.
What if we had hundreds of these vessels? This is going to transform ocean science.
Trying and failing doesn't bother. It's if we don't do everything we can do to ensure success.
So it actually made it. It made it from Plymouth, UK to Plymouth, US. And it took a couple tries to get it right. It did wind up getting stuck, not in the middle of the Atlantic, but about maybe 25% of the way, and had to be rescued back. And it was a very simple little hardware problem and came back, but it finally did make the full voyage. The point that I think is fascinating that Don made in his interview with me in the book, and really what I get a lot of is this notion of hybrid AI. And the thing is that there's this debate about old AI, expert systems or rule-based AI, and the new machine learning-based AI. And Don uses both when he designed this. And the example that stuck with me is machine learning, training data. You mean we have to sync how many boats for it to get it right? We can't afford to sync boats. We need rules, number one. Number two is, I think I mentioned this, that you have to be able to explain why you went to the right of the buoy. And the regulator has to see that explanation there. It can't be, oh, it's in the neural network. No, it's not in the neural network. Like we humans, we take tests, we get certified. So we know we're gonna go to the right because we passed the test. How are you gonna know? So rules-based, you can actually see the rule, right? You can't see the neural network necessarily. So he really in this, to get towards, and in the book, every time I saw autonomous, I took it out. Now I've been around it too long. Autonomous is a scary thing. I think I told you that even the Tesla car, in the manual, they call it, autopilot and this and that. But when you go into it, it's like driver assist, they start to call it, when they get to the legal manual. So autonomous is a great thing to strive, but don't forget about us humans. So semi-autonomous, I think, is a reasonable term, and I think Don and his examples agree with that. All right. I think we're just about at time. Yep, 1 minute over. All right, everyone. Thank you. Have a great rest of the week. Welcome to the students who this was their first class, and thanks for the picture.